Welcome, everybody. Now, once upon a time, if you asked an engineer what they knew about NMOS, they would have told you it was a transistor, and it still is. But really, all that has changed as we've all adopted SMPTE ST2110. Suddenly, we've got a new NMOS on the scene. And so rather than having to manually create and update the host tables containing IP addresses and host names, AMWA's Network Media Open Specification, or NMOS, was developed to assist in discovery and connection of devices in our IP world. So stay with us. Steve and Kevin are going to share the basics of NMOS, why it's useful, how you can monitor and identify NMOS and SDP issues in your IP infrastructures using unrivaled analysis tools. So put your questions in the chat. If we don't get to them during the session, if we don't hit that topic, we'll circle back to you. And take it away, Kevin and Steve, NMOS.
Cindy, thank you very much. Steve.
Yes, Kevin.
Here we go again. Another layer to the 2110 cake.
Yes, most definitely. Most definitely.
And this one is really interesting because I think most of our customers and that who've had SDI installations and that have basically built up knowing the control layers, what they are, what they do. Now suddenly everything's changed.
Yes, it has. Most definitely has here. So like what Cindy said once upon a time, if you asked most people about what NMOS was, they would have told you it was an in-channel metal oxide semiconductor transistor. Well, as a lot of acronyms go, you need to know the context. It is definitely not talking about transistors in this particular presentation. We are talking about the control layer for ST2110 and what has come about. So as Cindy said, rather than having to deal with huge spreadsheets and host tables and all those fun things to figure out what IP address I need to connect to and how I'm going to connect to that IP address, we have come up with this. Kevin?
We certainly have. So the standards organizations, including SMPTE and the AES, have created specifications for streaming of uncompressed video, audio, ancillary data over IP. And we're all familiar now with the 2110 standards and the 2022-6 operations. So these standards use RTP for video, audio, and ancillary data over IP networks. However, none of these standards completely specify the control or application plane, leaving significant additional work to be done to achieve useful interoperability in professional networked media environments. And to add this, a number of industry bodies have come together within the Joint Task Force and Network Media, so the JTNM, to coordinate how this might happen. Important thing to remember here, SMPTE ST2110 is a standard. NMOS is a specification. And a specification specifies something, often a requirement for the feature and characteristics a product or service must satisfy. A standard is a specification, often set by an unrelated body that sometimes, often a product or service, should meet to be acceptable. And Steve, this is where the fun and games start.
Yes, sir. So if we kind of look at a big picture of NMOS, quite often we're dealing with things. And like we said, this is where AMWA, the Advanced Media Workflow Association, comes in and has developed this control piece. And the whole ecosystem is kind of there in that light blue shadow, but we're going to take a piece and look at what is going on right in this area over here, which is actually where NMOS lives, which deals with the registry, the query server, and a few other pieces here looking at this. So we're going to be able to show you how this interfaces, because we want to be able to use things that we're familiar with. We want to be able to have a router panel, be able to hit source, find a destination, say take. We need to be able to use a switcher. We need to be able to possibly even just use our computer to pull things up and be able to look at them. So vendors have built these interface servers that interface to the NMOS system. But on the left-hand side here is the NMOS system, which consists of 3 different components. And we have the registry service, which goes out and helps find all of the receivers, all of the senders that are in your facility. It puts all of those into a registry database and then makes those items available for the external control, individual control stuff that would interface into a customer's particular equipment. Kevin?
So NMOS in some ways is like 2110, because obviously 2110 is a suite of standards. So we've got -10 for timing, -20 for the active video, -21 for the timing of that, -30, 31, 40. NMOS follows the same approach. And the 2 bits that we're going to look at here today is this ISO 4, which is the discovery and registration, and ISO 5. This is device connection management.
Yes.
As you understand, there's a lot to this. And as you can see, there's whole sections below this that we're not going to go into today. So it's just the discovery, registration, and control.
Yeah, these are the 2 pieces that actually make video work, that provide the connection when you hit source, destination, take, and something happens. These are the 2 pieces that take control of that and make that happen. And this is what 90% of everybody is using today. So in NMOS, there are devices, and a device represents a logical block of functionality. A node is the host for devices. So devices live inside of a node. And then devices represent logical things. And in this case, for ISO 4 and ISO 5, a device will be a sender or a receiver. So a sender could be anything that produces a IP flow. Could be a actual server, could be a device that's receiving a signal from a satellite and outputting that. It would be a sender. Anything that produces a flow. A receiver is anything that is receiving that IP flow and is going to do something with it. And it may be just a monitor, maybe a waveform monitor, and be able to look at it. So first thing we're going to take a peek at is NM04 discovery and registration and how this all works. How do we find all of these devices that are out there? Kevin?
As I said, so ISO4 is used for finding NMOS nodes and their devices. So it's referred to whether it's a sender, receiver, or could be a vision mixer that receives and sends on the
Yes.
network. And it describes their capabilities and advertises the location via the API. So these nodes will send their session description protocol files to the NMOS registry and discovery system. So we know you're here. We now know what you do. We now know what you're set up to do. And the session description protocol file has all the data that is needed to be used by the NMOS system, ISO5, to connect a sender to a receiver. So let's take a bit more at ISO4, Steve, and let's put that into an animation, because that's a pretty good way to show what's going on here. So as we said, there are 3 processes. Go on, Steve.
No, go.
Probably easier if you do it because you've got the button press.
So the registration API registers its resources into the registry table. We have the registry. So we have senders and receivers here that are going to find the registry service. So the registry service announces itself on the system, and the receivers will find that and they will post their SDP file. Now, the SDP file, which is the session description protocol, is just a text file that denotes in specific order and specific attributes of what a sender and a receiver do and are. And then the node API will find those nodes and use those. So one of the other things here is when the node finds the registry, it will turn around and it will do a post and post its data into the registry service, and it will loop through for every sender that it finds. It will go through and say, hey, here are all my senders. It will do the same for here are all my receivers. And it just does that until they're done. And then all of that data now lives in the registry service. And the registry service forwards that data, those posts, into the actual registry itself, which is the database. We don't want people directly accessing that database to possibly get in and muck the database up itself. So the database is made available to be able to look at via a query service. So you connect to the query service that has the ability to query that database for connections. There is a very, very handy tool out there, don't you think, Kevin?
Certainly. I mean, you and I have used this. It's Riedl's NMOS Explorer. It's free to download. This gives you a fantastic understanding of what's going on. And you can run these services we've just been talking about. You can run them on a Raspberry Pi. That's how processor intensive they are. And if you're new to this, if you want to get in and understand what's going on here, like we talked about with PTP, like we talk about with 2110, about building a testbed system, this can be a very cost-effective way of starting to understand what's going on. And as we've talked about here, with the nodes, the devices, the senders and receivers, all of that information that has just been attained using the ISO4 is now displayed here. And it now allows you with this graphical interface to actually start operating it, and we'll show that, you know, in a few minutes when we go live on the system. So as we said, on the left is the Readle system, highlighted currently the nodes. Then if we move across, the next section will highlight the devices, and then the senders and receivers. And as new devices are added to the network, they're automatically added. They appear, their nodes, their devices, and their sender and receive capabilities, which is quite a relief, isn't it, Steve? Because you can very quickly end up with a lot of nodes in a very small system.
Yes, yes. And this is a very small system. This happens to be my office lab, which is an itty bitty little system. And you can see already on the right-hand side over here, it already has a drag on it where there is many, many more receivers going down just in my little office system here and what we're looking at. So how this kind of all takes place here is the nodes find the registration service, the RDS. The nodes then will send their SDP to the registration service. The registration service then will write that data into the registry. So it's got a database of everything that's out there. Then the system will make that data available in the query service. So that's what happens within NMOS itself. The senders and receivers all appear in the registry. And now we need to deal with what do we do with that data that we can access via that query service.
So this is the ISO 5 piece, device control management. It says, and it's an API that provides the means to create a connection between a device and an NMOS compatible system and other devices that are used by the senders and receivers. So under the control of an NMOS administration server or user interface, the server will send a session description protocol file to the receiver for the sender to connect to. And as we said, in a conventional COPS IP system, the receiver will issue a multicast join to the multicast network switch for the entity to connect to the receiver. And the IP switch will then forward the requested multicast flow to the receiver. In a system where a COT switch is not involved, the session description protocol file will be sent to the receiver to set up the receiver's local interface, so its IP address and port, for the flow to be sent to the receiver.
So even in systems that do their own internal control of their routing, NMOS still needs to be involved because a lot of the receivers that you'll be switching into are probably not part of the control company's devices, and they can't directly control them. So when you make a switch using your internal control mechanism, the receiver still needs to know what IP address you're going to send to them. So in that case, that's where NMOS comes down and sets up that receiver and says, okay, these are the IP flows that are going to be coming to you, and then the switch will switch those IP flows to it.
I think we've got an animation of that, haven't we, Steve, now?
We do. So here is the system tied together with the registry, which is the NMOS on the left-hand side, and the user interface. So this would be the vendor's equipment that goes out to router panels, to switchers, to other devices that want to control things. The service is going to turn around and connect to the query service, find all of the devices that are in the registry, put them into their own server, and then have their user interface server that connects to their connection server to the query service, so that you can fill out your switcher panel here in this case. And then you can turn around and do a source destination take that will talk to the user interface, which will talk to the NMOS admin server. And the NMOS admin server will then issue the SDP file to the receiver to tell the receiver, now this is the IP that you need to tell the switch to forward to you in a conventional COT system. That receiver then will receive the flow, send out the IGMP to the switch, and voila, you now have the video coming out. This all happens in fractions, in milliseconds, very small milliseconds, if not microseconds. It is incredibly quick. So by the time you take your finger off of take and pull it back, it is switched. So
if it's done right, Steve, it behaves exactly like an SDI router.
Exactly, and works incredibly well. So
we've made references to the session description protocol file. And for those of you who are at the beginning of this, we did hint that we've done a little separate video to try and do this whole subject justice. So what you're going to see here is the shorter version. We go into this in a lot more detail, and that video is up on the leader YouTube channels now. So let's take a dive into the session description protocol file, Steve.
yes.
And the great thing with these is, like with PTP that we recently talked about, fortunately, we as a broadcast industry are not the first people to deploy this. We are not on the bleeding edge, are we, Steve?
No, we are not. So SDP files, session description protocol files, have been around for some time. It's actually an IETF RFC 4566 that has been around for a while, that has been used in the IP world for some time. It just happened to have all of the fields and all of the connection data that we needed for video. So looking at the table here, there are several different pieces going through here. And at the top, what do we got up at the top there, Kevin?
We've got the header information. Who's the source? Where's it coming from? What format? And also an indication here, in this particular case, that it is 2022-7, that we're running seamless switching, as it can indicate here that we've got both a red and blue network. So this is the kind of high level introduction to what's about to come your way. Then, if you look at this, you'll start to see some parameters in here in the text that you're going to go, I recognize those as a broadcast engineer. Look, there's YCBCR 422. There's a width of 1920. There's a height of 1080. There's color imagery, BT 709. There's depth, 10. All of these things you'll be familiar with from your video payload ID, so SMPTE ST352. They're all contained in here. And as I said, this is a -7 session description protocol file. So that's the primary. And below that, we've got the backup, the secondary, which should be identical, obviously with the exception of the multicast flow address, because
Yes.
it's going to come on a completely different path to you. So you've got resilience and redundancy on your network.
And to be correct in the world of -7 and IP, it's not really a primary and a secondary network. It's twin feeds that actually go into a packet picker, and whichever packet shows up first, it's going to be grabbed. So you may see differences up here in the top where it says primary and secondary. That was the first stuff that was laid out there. You can put any words in there that you want. You could put red and blue in there. And as long as that's what you call up down here when you say, this, everything I've just given you is for the primary channel, everything that I've given you is for the secondary channel, or everything I've given you up here is for the red network. Everything I've given you down here is for the blue network. It's whatever verbiage you define up here in the top. So you may see people call it out different ways. Sometimes they'll say Duke 1 and 2. Sometimes it's just different verbiage. So this defines how you're going to call the two services that you're going to use for the -7. And then this is talking about them. So if we open this up a little bit bigger here to be able to look at the SDP file itself, we've got several different fields in here, Kevin.
We certainly have. So as I said, we've got the multicast flow address, that the stream that we're interested, or put it this way, the stream we're being told to connect to and look at, because that's what's happening here. We've then got details, as I highlighted, about the video format, that any broadcast engineer will look at those and go, actually, I recognize most of those parameters. And as Steve mentioned, the primary and secondary are the same, except for that address of the multicast flow. So like all these things, I'd recommend take a look at these, get to know them, because this will allow you to use that knowledge you have as an SDI engineer to identify where a potential issue lies within your system and then go into the IP part of it. It could be, and we're going to do some troubleshooting a bit later on, so I won't jump ahead on that one now, of how the session description protocol file can help you identify where issues lie in your system. I'm going to leave this bit to you, Steve, because this, I think I understand.
Yeah, so DNS, Domain Registry Services here. The registration discovery. So this has been used forever in IP. That's how we can type a name in and actually get an IP address. So devices will turn around and put their names or their service discovery in a DNS. So the domain service directory discovery here. And if you think about it, it's like, you know, in a browser, if you type google.com, that's going to go into a DNS server that has a table, and it's going to look up in that table to find out what the IP address is of Google. And it's going to connect you to the IP address of Google. So DNS also provides the ability to discover hosts for a specific network. And that's where using DNSSD discovery, we use that within NMOS. So the registry uses DNSSD to publish itself, and that's how the nodes know and they see that message from the DNS SD from the registry service in NMOS. It says, hey, this is me, this is who I am. And now the nodes know who to send their SDP file to. So the control within the RDS system may be on a different network or subnet in a 2110 system. And sometimes the DNSSD can't get across. Sometimes it's within the same network that the receivers and senders are directly tied to for control, but sometimes the NMOS system is on its own little network island, and we need to be able to route across from the NMOS island to the control interface into the senders and receivers. And sometimes that may or may not need help getting across. So what we have here is we have our RDS here, our NMOS system with its registry going into a network switch, which is a router in this case, which has the ability virtually within its route tables to be able to take network B routed across to network A, but the RDS discovery system, sometimes that announcement in the DNS doesn't make its way through to the nodes. So sometimes it needs help. Sometimes we can just use DNSSD multicast and it will connect straight through. Sometimes, though, we have to help it a little bit and maybe point to where the source domain is so that I can get through that router and go up to the RDS. So that's probably one of the biggest things that needs to take place within NMOS is getting this route so that the two networks can talk to each other if it is on a separate network plane and needs help getting across there.
And obviously, Steve, as these systems start to get bigger and people start to merge their IP islands, you know, we're going to start to see more of these challenges of having to tunnel through routers and that to see devices that the guy's saying, well, in the SDI world, I could see that source. Why can't I see it in an IP world now?
Yeah, and that's because of that routing.
Yeah.
But one of the unique things about NMOS is it is HTTP. You can take your computer, your browser, and you can go into that network switch and you should be able to reach the registry discovery system, the NMOS system, and you should be able to reach any of the nodes that are in the system. All you need to know is their IP address and their port number. And you should be able to go into a browser and type in the IP address for the RDS, and you should get a message back from the RDS saying, yes, you've connected to me. You should be able to do exactly the same with the nodes and have the nodes reply back. And actually doing this and getting in and then perusing those tables, one of the nice things, you're not going to change anything within these tables. So you're not going to disrupt service or anything else. You can get in and see what all of this stuff looks like.
And here we've got an example, haven't we, Steve, of
We do. So this is my little system here. And if we turn around, you can see that in this case, I went into 192.168.50, 236, which is the address of my NMOS registry system. It's on port 8080, and I get a response back. That tells you that you have connectivity to the NMOS registry system. From that same point, you can turn around and put in the IP address of one of the nodes. So in this case, one of my nodes is 192.168.50.203. It's on port 3000. And I will get a response back. So what you need to put in here is the IP address, the port /X NMOS. And that is the same for whether it is the registry service or a node. So if I walk out on the wild side here for a second. Drop this back down just a little bit.
You couldn't resist it, could you? I knew you'd do this.
I know. But let's see, it's 236:8080. And if the world is good to me here, there it is. And I got a response right back from my registry system. Exactly what you see in here. If I open another tab, I don't have to, but I'm just going to open another tab. And this case, I put in 192.168.50. Who is it? 230. No,
236.
Nope, 236 is where we just came from. 203.
203, sorry.
203:3000 /X-NMOS. I don't want, you can see I've been playing in here before. And I get a response back from my node. So I've just put in the address for a node, and now you can see what's in that node. So you could turn around, and it's a good way to learn about this stuff is you put in the next items that say node. Need to roll my cache away. Okay, it's running version 1.2. So you could put in the 1.2. And so then it talks about itself, sources, flows. Now, some of these items will not be filled out. Not everybody fills out every single one of these pieces. So some of these you're going to put in and you get nothing back. Some of them you'll put in and you'll get gobs of data back. So it's just something you can do and be able to learn this stuff very nicely, very quickly, going through all of this. So I highly recommend that if you want to learn NMOS, you want to learn SDP files, the SDP files are defined in the SMPTE standards. If you look at the 2110-10, and let's say the 2110-20, which will define the SDP for video, it will tell you what all the fields are and what stuff is. And you can also pull that RFC that we mentioned in here. And this whole webinar that we're going through here, like I said, will be made available on our YouTube channels in just a little bit.
So that's great for sort of verifying that that control piece is working. As we discussed, the session description protocol file can be your best friend when it comes to understanding what your receiver is being told to look for. Because the number of times we've had calls saying, well, I've got video and I've got captions, but I've got no audio. It's a case of going in, looking for the session description protocol files. In some cases, we've had it that we've got a -20 and a -40, but no -30. And we've got an example here of a session description protocol file that highlighted quite an interesting little anomaly, didn't it, Steve?
Yes, it did. Yes, it did. And as you can see in this particular SDP file up here on the top, where it says A equals group dupe, it is called red and blue, and it is called out for red and it's called out for blue. But if you've been around 2110 for a little bit, you'll know that there is a packet type for video. There is a packet type for audio. There is a packet type for ancillary data. The packet type can be any number from 96 to 127. The industry has kind of started using almost exclusively 96 for video and 97 for audio and 100 for ancillary data. Those are kind of the norms. There is no standard there, though. You can use any number between that range that you want, but typically 96 is what's called out for. But one of the unique things is the SDP file here calls out the packet type in many places. And in this case, down here on the bottom, blinking down there, you can see that it says that the video is packet type 97. But elsewhere in here, it's called it out as 96. So which packet type is the receiver going to look for? Is it going to look for packet type 96? Or is it going to look for packet type 97? And this was a real case that a customer had. And the unique thing is you will not see this SDP file in a control system laid out like this. You're going to see normal control system stuff where it's going to have a field. You put in the IP addresses. It's going to have a field where you say, hey, this is 1080i or this is 1080p. And you're going to have different fields that are just, in a normal control system interface. You will only typically see the real SDP file in the receiver after the control system has put it together. So troubleshooting some of this stuff and looking at what's in the control system can be a little iffy. The best place to look at this stuff is in the receiver itself and see what the receiver's actually receiving. Most receivers have the ability to actually give you the actual real SDP file and lay it out for you.
As I mentioned earlier, 20 sorry,
go ahead.
I was saying the next one. This is where things get interesting, because I mentioned 2110 is a standard, NMOS is a specification, and different manufacturers interpret some of these parameters differently, don't they? And
Yes, they do.
This is a very common one that we see get called up. It's the field we're highlighting at the top, which is basically the origin. It's where the signals, where the stream is coming from. And receivers can be very picky about recognizing them and even accepting the data they receive from them, can't they, Steve?
Yes, they can. So you may have a receiver that doesn't parse every single field of the SDP. You may have a different receiver that parses every single piece of the SDP file, and they'll throw out things on pieces that another receiver doesn't throw out just because it isn't important to them, so they don't parse it. But then you'll have another receiver that parses every single piece, and it has to match exact. So different receivers will behave differently. One of the things the specification for an SDP says in that origin is you can have a name or no name in that origin with the IP address. And if there is no name, you must have a dash in there where the name would be before the IP address. And so in this case, the dash is missing because there is no name in this particular origin field. And we had a receiver that threw this out because there was no dash in there, and it wanted to see the dash. It was parsing that field and says, hey, the standard says thou shalt have a dash in here if you don't give me a name. And there was a name field, and it didn't have it. So if you have something like this, where it actually puts the name in here, this would be perfectly fine without the dash. But if you don't have the name in there, you need to have that dash in there.
So that's a good one. Now, there is another one we've come across, which is getting a little bit more nuanced. It's where the session description protocol file makes detailed reference to the grandmaster, the source of PTP. And this is an area where some receivers are basically very picky and they won't work unless they see that. Some are even worse, where they will only work if that grandmaster ID is the same as the one they're connected to. And as you can see here, we've got it on both the primary and the secondary. And one of the areas we're concerned about here is, say the best master clock algorithm kicks in, a new grandmaster is selected, but the session description protocol file still refers back to the old one. Steve, it's it's a 21st century problem, isn't it?
It is. It is. Because unfortunately, as you'll see in another instance here, the SDP files are sent one time. When the receiver finds the registry service, it sends its SDP. It's done. It's in the SDP. If something changes, you need sometimes to kick your system to turn around and tell it to reread because something has changed in what you're doing.
Should we jump through to that example? Because we'll show them these slides in a few minutes when we go live, won't we, on your system?
Yeah.
So let's go to the gotcha.
So here's a service here. It has registered itself. It sent its data. And the sender, in this case, registered itself. The receiver turned around and was set up for that particular sender. And let's say, and this kind of happens in trucks, where you go out, you set the truck up, all your cameras are, let's say, in 1080i, because the last show you did was all 1080i. The entire truck sets up in 1080i. Then you find out, oh no, I got to set all my cameras for 1080p. So the engineer in charge changes all the cameras 1080p. Nothing ever tells that receiver, because it's already been told what the service is, and that receiver is still sitting on 1080i. It has to be told, you got to send a new SDP to that receiver to tell it that things have changed. And you can turn around and actually screw things up. You would actually have to go in and do another source destination take to turn around and resend that SDP file, so that it looks at the query service and says, oh, yeah, I got to update my tables. And oh, by the way, no, it's a 1080p service, not a 1080i that you woke up to. This is real. And if you think about, especially it happened, done this with guys with trucks, and, you know, all he did was change the cameras to 1080p, and virtually every receiver in the truck went belly up on him. And if you're doing this setting up just before a show, there can be a little bit of anxiousness there, that all of a sudden your truck went belly up, and you find out that, no, I just have to go in and reset all my receivers and have all my receivers re-up to what changed. It's not quite like SDI, where the VPID, the video payload ID, is part of the video. And as long as you're looking at the video, you know what the format is. The format is coming to you from a different source. And if you don't resend that, you may get into issues. So this is something we haven't quite 100% developed, that the user interface system out here would have to keep a updated massive table of what receivers are connected to what service. And if that service change, it needs to know that, hey, I need to automatically update all my receivers that are connected to that service. Personally, I have not seen a user interface system that does that. I'm not saying there isn't any, but I have not seen one that does that. There may be some out there that do that, but I haven't seen it yet. So it is rather unique.
Let's throw it out there, Steve, to our audience. If you know of anybody that does that, let us know, because we'd be interested.
So I am going to bring up here. So this is actually looking at a leader LV5600. I'm looking at PTP, but I've got absolutely no video coming in at all. If I go look at the picture, no signal, nothing's coming in here. If I scoot over here, Riedel, so here's my source I'm going to deal with. And if I click on the source, it tells me, hey, do not drop the source on certain fields over here because they're audio. But down here is a video, so I can actually drop that source there. And guess what? The video just showed up, and I now have bandwidth. And I can do the same here for the audio. If I scoot down here, get into my audio receivers and say, hey, audio, I can, for that same service, drop that audio, and boom, I now have -20-30 for port 1, my red network, -20-30 for my blue network. And guess what? I now have picture. I now have audio that I didn't have before. So this shows very easily how this turns around and works. And I can turn around and do the same thing. Excuse me for a second. For a Fabrics QXL here, here's my QX, and I can drop, and boom, you can see as soon as I drop that, I had video. Now the Fabrics gives me this beautiful little green light screen here that lets me know that everything was perfectly fine with the video I dropped. And if I drop the audio, do a patch, all of my audio comes up and looks at that. Now, the other thing that these systems give us here, I got to move that switch closer, is the ability within the devices themselves to look at the NMOS. And you can see from my video up here at the top, it was sent to me. It is HTTP, and I get a 200 code. Hopefully, most people are familiar that HTTP 200 codes are everything was good. You would get a 400 code if something was wrong in here. And so it's telling me here's the data that was sent to me for the video. Here's the data that was sent to me for the audio. It was good. And in the bottom window down here is the actual STP file. So here's the source that was sent to me. And down here is that format information we were looking at, giving me the width, the height, the exact frame rate. And on the Fabrics, if we go into double click on this, I can look at my video STP file, my audios, and my ancillary data if it was there. But there's the video, and it highlights the primary fields it's looking at. So it allows you to see that this data, and you can see the service come in and what my video and audio and all the IP addresses, the data rates are doing and looking at this stuff. So it allows you to see many different things. If you go in and have an STP file like I have right here, if I turn around and screw one of these fields up to something that doesn't make any sense, like, so got an issue, I got a 400 code, bad request, width 1920, height 180. It's not, and you can see down here in the STP, the width 1920, 180. So it does tell you exactly what didn't parse and what was the data that came out wrong from the sender. And if you were to put a USB stick in the front of the box, you can turn around and copy this as a text file and send it back to the vendor that created this data.
So Steve, I'm conscious that we've got to the top of the hour. Do you just want to bring the slides back up? We've got a white paper on this that I can take absolutely no credit for writing. Steve did this one. And there's a QR code on the screen where you can now register to download that. And we appreciate there was a lot of information we've just gone through in the last hour. So if you want to catch up with this video, it will be available with the next slide on our various YouTube channels, where also there is a wealth of product and technical test and measurement information available for you to enjoy. So subscribe to this channel and you'll get posts of updates when new videos appear, because as people ask us interesting questions, Steve, we sometimes think, well, let's just do a video. It's easier to explain it that way. And if you can't get enough of us, we also have an audio podcast where these sessions are taken. So via your various podcast suppliers, you'll be able to find us as BA Video Leader, the Ultimate Test and Measurement Podcast. And this will be appearing on there very shortly. So as I said, unfortunately, we've got to the top of the hour. We've not been able to take any questions. If they have come up in the chat, we will get back to answering them. And I think at this point, we'd like to thank everybody for joining us. I hope you found it interesting and informative. And possibly next time, Steve, we'll do like we did with PTP and let the audience ask the questions and go from there.
You got it, Kevin. Yes, everybody, we want to thank you. Sorry, we felt it was better to give you the information in here and take your questions afterwards. We will answer 100% of all the questions you guys have brought in. And we want to thank you for your attendance. And I hope this was a worthwhile session for you. Thank you very much.